everybody. Thanks for coming and braving your day two hangovers and combined with the post-lunch food coma. Welcome to Attacking Ajax Web Applications, part of a 17-part series put together by Jeff Moss of Ajax Talks Back to Back. I appreciate being last. Thank you, Jeff, if you're here. Okay, what are we going to talk about? First, we're going to just give you a little introduction about who we are, why you should care about this talk and not leave in the first 10 minutes. We're going to give you a bottom line up front about how Ajax changes web attacking. Then we'll give you a little bit of background on the Ajax technologies, just so you have the understanding so we can go more in depth on some Ajax attacks, like discovery and method manipulation, cross-site scripting, and cross-site request forgery. And then we'll go through our observations of some popular Ajax toolkits and how they do under some of these attacks. Okay, who are we? So Zane Lackey and I are consultants for ISAC Partners. We're an application security company headquartered in San Francisco with a sizable office in Seattle. Why do you want to listen to this talk? Anybody who reads the paper or Time or the Register knows that Web 2.0 applications are kind of undergoing a reverse renaissance of security, right? It's the dark age of security for these guys. There's a lot of money chasing a lot of bugs, and if you're not hearing about Yahoo worms or MySpace worms, it's a slow day on the tech section of the USA Today. And so what do we want you to walk away with? We want you to have a basic understanding of Ajax. We want you to know how Ajax changes web attacks from a basic level, have some in-depth knowledge on how a couple of those attacks can actually be taken out. And we want you to form your own opinion about whether you should trust Ajax frameworks to take care of security for you. Not a loaded question at all, right? So we'll move the shameless plug slide all the way to the front so you guys don't run out during the end while we do it. I want to thank Brad, Jesse, and Scott of ISAC Partners, helped do a lot of this work. Amit Klein and Jeremiah Grossman, want to give them shout outs. They do a lot of very good work in web app security. Read some of the papers they've written, and Rich Canning's at Google. Here's our 2 of the 17 books that Himanshu Dwivedi's written in the last 9 months. And you can go get a signed copy if you ask us afterwards, and please send us your resumes. Okay, so Web 2.0, what is it? It's a new honeypot for venture capital, and that's why it's so popular, right? Use the words Web 2.0, India outsource, Flash, social network, maybe throw in a GUI demo that doesn't do anything, and somebody's going to throw $6 million of Series A at you. I highly recommend it. It's a great career path. Works out for that MySpace Tom guy. He's doing okay. But really, Web 2.0 isn't a technology or a group of technologies. It's an attitude. It's kind of a group. It's a set of attributes of these new kind of sites that are coming out that change the way people interact with the web applications, but don't necessarily change the underlying technologies. Some of these new attitudes are things like user-created content is becoming big, or in the case of YouTube, user-pirated content, social networking, and building up social networks where you rate people and you have systems that understand who your friends are. Highly interactive GUIs is one of the big parts and one of the big draws, and mashups and plugins, right? Because if I couldn't get JavaScript from one site, I'd like to get JavaScript from 7 different sites right now. And that's what mashups and plugins are about, and those are becoming actually more and more popular, and we'll talk about those at the end. Not all Web 2.0 sites use new technology. If you look at YouTube or MySpace in WebScarab, which is, anybody here use WebScarab? It's a very excellent web application proxy put out by OWASP, written by a guy named Rogan Dawes, really cool guy. I highly recommend it instead of all the commercial ones. But if you run WebScarab and you run your web browser through it and you open up MySpace, you'll notice that it's actually really boring. There's lots of iframes, there's Flash content to actually do the content stuff. They use divs, they use some HTML forms. Not a lot of real exciting technology in MySpace, but still it's kind of held up as in the pantheon of Web 2.0. Whereas things like Google Maps, MSN Virtual Earth, some of these super high-tech, what are almost experiments by these big companies, use lots and lots of new technology. And so we're trying not to use Web 2.0 too much, and we're going to talk about really Ajax as the umbrella under which all these new technologies fall. Ajax is very controversial for people to use it. One, because everybody fights over who coined it, and second, you can have Ajax with neither JavaScript nor XML. But I'm going to use it because I don't really care about what Tim O'Reilly thinks. It's really an umbrella term for web technologies where rendering is done client-side and communication with the server is asynchronous. Generally, that uses something called the XML HTTP request object, which we'll talk about, and where the X comes from. And generally, you're using not JavaScript, because that doesn't exist, but this thing called ECMA script, which happens to be the exact same thing as JavaScript, that you'll use ECMA script or JavaScript to do client-side requesting and client-side decisions about how data gets formatted. And that's kind of the umbrella of AJAX, and that's what we're going to be talking about. So some examples. MySpace. Who here has a MySpace page? Let's see it. No, it's okay. Come on, put it up. That doesn't mean you're necessarily a pervert. You just have a 40 or 50% chance. Wow, and they're all like middle-aged white men who raise their hands. That's a little frightening. So MySpace. MySpace is, why is MySpace in the news all the time, right? Well, I talked about user-created content. This is, when you open up this MySpace page right here, you get lots of HTML and script written by a guy inside of a bear suit, right? That kind of is the issue behind a lot of the Web 2.0 things, is that the model between the people you trust and the people you don't trust has really gone a lot fuzzier, right? When you go to CNN.com, you know that CNN.com made that content, right? When you go to MySpace, I dare you to try to go through the HTML and figure out which and which div tags came from MySpace and came from somebody in the bear suit, right? But like I said, while MySpace has that kind of attitude, it's not that technologically advanced. And you probably can't read this, but this is just a GET request to get somebody's homepage, that homepage that we just saw. And the response is this huge, unbelievable large chunk of HTML. You know, how many people raise their hand and say they have MySpace pages? This is the same number of people that have seen the MySpace error page, right? Because they throw errors all the time, and it's incredibly slow. And one of the problems is they don't really use AJAX technologies. A good counterexample, as kind of the other end of the technologically advanced Web 2.0, is Google Maps. Google Maps uses dynamic updating. You can see here that there's a page missing that's intentional. That's because it's that's a PNG that hasn't been downloaded yet from the server. You can see the asynchronicity right here in the screenshot, right? And if you look at the Google Maps traffic, what you see is a lot more small requests that come back with much smaller traffic, and something that maybe doesn't even make sense when you first look at it, right? Often when you look at AJAX traffic, it doesn't make any sense unless you look at it in the context of the entire communication. In this case, we have what looks like, what? What does that look like? Properly formatted what? They're coordinates, but what is this code? It's not HTML, it's JavaScript, right? Now, it's JavaScript without a script tag, it's JavaScript without any definitions of variables, it's JavaScript without context. And that context comes from the AJAX stuff that was already downloaded into the browser. So why should you care about Web 2.0 security? I mean, so far, it's mostly been about bugs and teenage hangout sites. Well, one of the things Web 2.0 represents is a real change in the way people interact with the web. You know, I'm not an old guy, right? But you know, it wasn't too long ago that I was in high school, and when I hung out with my friends online in high school, that made me a dork. It meant, you know, women turned out were not attracted to men whose all their friends were online, or girls, I guess, to boys whose friends were online. And that wasn't too long ago, but my youngest brother is in college right now, and he's an unbelievably cool guy and the big man on campus, and he has an incredibly large MySpace page and spends 80% of his waking hours online. There's been a huge sea change in just our generation of people of what it means to interact with people and how much of that's going to be online. I bet if MySpace had a field to say when you sign up, what's your social security number, mother's maiden name, and parents' bank account routing numbers, that 80% of the kids that sign up would put it in there, right? They have absolutely no fear as to the interaction with it. They don't have that kind of adult trepidation of the computer and the internets and the cyber villain web of all the bad things that can happen. And that's an attitude that is going to expand, and once these kids all become the consumers, it's going to become dominant. It's going to change the way people interact with the web from a security standpoint too. And the technologies, while they're starting with innovative companies, often who are taking venture capital and burning it pretty quickly. Oh, thank you. That makes it a lot easier to give the talk since I can't see now. I appreciate that. They're already moving. These technologies are kind of, there's a trickle-down effect to the more traditional things. We've already seen AJAX in things like financial institutions. We have a healthcare client that's deploying AJAX. The government is deploying AJAX. So what used to just be something that you do as a startup is now real sites that actually are important is using it. And the bugs are affecting people now, right? People are estimating that over 1 million people got adware onto their machine because of the combination of a MySpace cross-site scripting bug and an unpatched IE 0 day, right? So you know, how many people in here have teenage kids? Okay, I guess that's basically saying who here is the oldest in the oldest demographic of people that come to BlackHat. So you people that don't want to raise your hands, you should be worrying about these things for sure, because you would be shocked, I think, if you put Ethereal on your network for a day and saw how much information your kids are willing to give to the net. And it's only getting worse. So we're going to do the bottom line, and we're going to talk about how does AJAX change web app attacks. We're going to do this quickly up front just so you guys have an idea of what to think about for the rest of the talk. Okay, how does AJAX change discovery, enumeration, and parameter manipulation? Parameter manipulation being kind of the old standby and still an excellent attack against web applications. In the Web 1.0, and I'm sorry that I'm using these terms, but this is the best way that I can get myself in the paper, is by using terms like Web 1.0 and Web 2.0. In the old Web 1.0, fingerprinting of web applications and application server platforms is a lot of work, right? You have to get an account on your bank site, and you have to use all the functionality, and you've got to walk through it, and you've got to record all the traffic, and actually express all of that, and figure out the procedure call mechanism, to figure out all the things you can do was a lot of work. In Web 2.0, it, a lot of ways, becomes a lot simpler. It becomes a lot simpler because a lot of this functionality is now moved to the client, and the client often has lots of information about all the functionality the server can do, right? And so it's just sitting there in the client, and if you can parse it out, it's a lot easier than walking through and spending a couple hours playing with a web app. The bottom line is AJAX enumeration is more complicated because there's not a standard way of AJAX frameworks to store what methods can be called on the server. But in the end, it's a much richer attack surface, and it can make it, with one request, you might be able to get the information on the entire system, kind of like grabbing a WSDL, instead of with many, many requests. Cross-site scripting. In the good old days, we do things like injecting script into HTML text, right? The browser got two things from servers. It got HTML that was generated dynamically, and it got JavaScript that was generated statically. And there's a couple ways you can get script in there. Most of them are pretty well understandable, and it was pretty well understandable how to protect against it. In Web 2.0, now we have dozens of different types of protocols on the wire, and you really need to understand all of them to figure out what is dangerous and what is not. So there's a lot more opportunities for cross-site scripting, but in the end, the cross-site scripting bugs are a lot more complicated. They have to be a lot more customized for the app and for the communication method. And so the good old script alert test is not necessarily going to work. But just because you do that on an AJAX app and you don't get a pop-up box doesn't mean that there's not a vulnerability. Injection attacks. These are the good old attacks against back-end query technologies like SQL, LDAP, XPath, and XQuery. People are still using them. There are some interesting possible new attacks against injection attacks against front-end protocols, but we're not really going to talk about them because I've seen that like in one situation. It's pretty specialized, but if you think about it, you know, you've kind of got a query engine now working in your client, right? If your client is putting together a JSON request in Firefox, then perhaps if somebody has user-controlled data that goes to the server, comes back to you, and that gets put back into that request, that they might be able to do some injection attacks against that, but it's pretty rare. Bottom line, these back-end vulnerabilities are still exist, but there's more fun to be had on the front end. I wouldn't say there's a big change with injection attacks for AJAX. Cross-site request forgery. We'll talk about this in detail. In the good old days, cross-site request forgery, in the good old days of cross-site request forgery being 6 months ago, right? We're not talking about 1999. It was a big issue. And in AJAX, it's an even bigger issue. And it's more complex, it's harder to find, it's harder to understand, but in certain situations, it's much, much worse than you were able to do in the good old days. And we'll talk about this a lot. Okay, so Zane, you want to give a little background on AJAX?
All right, let's take a look at the AJAX history. Before everyone started doing AJAX, there was the iframe approach where you could get the same basic functionality out of it. What you'd do is you'd create a hidden iframe that was 0 pixels so that the client wouldn't see it, or excuse me, the user wouldn't see it. And what you could do is you could write script in the page that could call functions in your iframe, and that could send data and receive data from the server, and it wouldn't update the main page. So you'd get AJAX-like functionality with an iframe. So let's take a look at AJAX now. AJAX is basically the XML HTTP request object, which is abbreviated XHR, which is just as hard to say. In Internet Explorer, it's implemented as an ActiveX object, which is going to change in Internet Explorer 7, where it's going to become a native object like it is in Firefox. As you can see on here, this is a simple instantiation example. you take a look at the object and you see if it's an ActiveX object or if it's a native object, and you instantiate it like that. So, a very, very basic example AJAX request and handling a response. You create the object, you set up whether you want to do a get or a post in your target site, and you set your callback there as update page, and then you send off the request. And when the response gets back, it hits the callback function, and it checks for some state and everything to make sure it's fine. You've got a HTTP 200 response header, and then you pull the response text out of there. So, the real beauty of the XML HTTP request object versus the iframe. It's not restricted to HTML forms with your name value pair. You can set any arbitrary data you want. And it's asynchronous as well, so you can, whenever, you just send off your request, and whenever data finally makes it back, it hits a callback, and you're good to handle it. There are all types of downstream data you can use. You can use anything, really. We're going to take a look at a couple of these very briefly, because these slides are kind of boring. XML. So this is the traditional method of doing AJAX. Nobody really likes to do it because it's so heavy. There are much lighter ways to do it. Take an example of the client sending up a simple request here for a zip code lookup and get back some data in XML for some Seattle zip codes. So another way to do it is for the server to send back full JavaScript. Same client request, and the JavaScript comes back down from the server, which is plugged right into eval. JavaScript arrays. Same sort of thing. The server sends back JavaScript arrays, which then JavaScript that's already running in the page watches to see those arrays got modified, and it updates the DOM with the new data. JSON, the lightweight way to do AJAX, which in half the examples is just as heavy as XML, actually. Same request, and it looks a lot like JavaScript arrays, actually, but it's a little bit different. Microsoft Atlas, which actually looks like JSON. Like I said, these slides are a little bit boring. We're going to go through them quick. Google Web Toolkit sends back data, looks similar to that. And upstream options. So your traditional method to do an upstream option was just a get, which is really lightweight, really quick, and really insecure, as we'll show later. Upstream option is post, which is what the DWR framework uses. In this case, they do a post with the data being your variables and the method name that you're going to call, and that gets invoked. SOAP. SOAP is similar to basically doing XML downstream in that it can be done, and there are some people who do it, but it's pretty heavy, so not many people do it, actually. XML, same thing. Traditional way to do it. When it's done upstream like this, it's called a REST web service, and it's pretty heavy, so there are other ways that you'd usually go about doing it. And let's take a look at the fun stuff, the bugs.
Thanks, Zane. Can I get a round of applause for Zane? This is his first major conference, and I am so proud. I'm sorry. Told myself I wouldn't do this, but. Okay, so we're going to talk about the bugs. So we'll talk a little bit about discovery and method manipulation. We'll give you some examples, some concrete examples. Like I said, playing with parameters in a web application is still an excellent web attack. This is the first attack and the latter attack. Who here ever bought anything off the web, perhaps in between 1995 and 1999? Anybody? Did you actually pay the price that you were supposed to pay when you bought that? Anybody not pay the right price? I admit it, I got a really cheap TV once. And why did I get a cheap TV? It's because in 1996, if you opened up a web store, an e-store, or a click and mortar store, then you would have your shopping cart would work by having hidden fields that represented the cost of the actual items in the shopping cart, right? People don't make stupid mistakes like that anymore with parameter manipulation, but they still make mistakes because the business logic and applications now are much, much more complicated, and so there are a lot of really complicated ways you can twist it. For example, here is something that may not look like parameter manipulation unless you think about it a little bit. This is let's say this is a normal Web 1.0 application, and I'm doing a GET request to do a transfer of money. Obviously, I probably need more information here, right? But the amount is this number. Anybody know what that number is? Does that look familiar to anybody? Any idiot savants in here? What? It's not a phone number. Sorry? Okay, I guess idiot savants mumble a lot. Could you speak up, sir? That's 2 to the 31st plus 1, right. So I put that number into a web transfer money in my bank, what might happen? What might happen if somewhere, after the, maybe the function that tests whether I have enough money uses a signed integer, right? And so it casts that unsigned int to a signed integer and ends up being a negative amount of money, which is supposed to be filtered out earlier. And it says, sure, you have enough money because you have more than negative amount. And then it lets this transfer go through. This actually worked in a web pen test a couple years ago. So parameter manipulation actually still exists. Figuring out the hard part of parameter manipulation is finding all the parameters and figuring out what they do. Like I said before, that's a lot of work, and that's why you actually have to pay Sanctum a lot of money to buy their web app security scanners, because that's where a lot of the intelligence is to be able to pretend to be a human and walk through an application and find stuff. Sanctum can give me money later for that ad. But is it easier in Ajax? Well, sometimes it is. There are really kind of two broad categories of types of Ajax. Some people call this client SOA versus HTML++. The client SOA side is really a client-server proxy side. It's Ajax as a GUI in front of a web service, right? You do this in a situation, in this situation, your framework, your Ajax framework, looks at server-side code where some of the methods on the server side are tagged as, I want people to call this, right? I've got a function called transfer money in my Java code on my server side, and somehow I say to the framework, I want this to be called by the web. And so your framework code automatically goes through and it tags those and it makes them public, and then it generates a JavaScript proxy that then maybe even has functions of the same name that exists in the web browser, and then it's up to the developer to write like the formatting code in the web browser that talks to that Java proxy, right? So it's a lot like a web service. When you interact with a SOAP web service on any platform, the first thing you do is you create a SOAP proxy object and you point it at a WSDL, and all the magic happens, and that proxy object now represents the server, right? So now I've got a little thing in my browser, and I pull the lever here, and it makes the lever pull over there magically. That's the idea of the proxy. And obviously, a proxy like that has to know the name of all the methods. Now, theoretically, you'd be able to write an Ajax framework that didn't give all that information up front before somebody logged in. It turns out nobody has, but that's theoretically what somebody could do possibly. And in those situations, discoveries is pretty darn easy, because in some place in your browser's memory, there's a list of all of the methods on the server, and a list of all of the, maybe not the types, but the number of arguments they take. The other kind of Ajax is called client-side rendering by some people, or HTML++. It's really just a way of making the HTML a little cooler, and a lot of times it's in a situation where the framework doesn't want you to have to do any work on the JavaScript, so it makes it all magically. This is how both Microsoft Atlas and Google Web Toolkit work. Often that there are functions, and you can dig through them, and sometimes you can't. And this is a much more complicated situation to find these functions, and we'll give you some real examples later. So let's talk about cross-site scripting. Who here knows what cross-site scripting is? Now, see, finally a question that if you don't raise your hand, that you're probably my wife in the front row. Wow, I'm married to a lot of people today, okay. So cross-site scripting is basically, the browser has a security model, right? And if you have script running in the silo of a web page, then theoretically it can only break out of that silo in very specific issues, very specific situations, right? And the whole idea of cross-site scripting is, I want to get script into that silo. And the best way to do that in the good old days was I bounce that script off of the server that you're talking to, right? There's lots of ways that you could do cross-site scripting. Kind of the two generic real ways that people used a lot was A, to put a new script element into HTML, right? Like if I'm posting on my message forum where I discuss sports scores, but I put a script tag in there, and it gets put into the HTML later when it gets rendered server-side, then that comes up to Firefox, and it has no idea that that script element wasn't supposed to be there, right? I created a new script element. And then the other way that people saw a lot was in situations where user-controlled data, this would often be something like document.url, like the actual URL you're going to, where user-controlled data ends up getting automatically composited into tags, like normal HTML tags. And so you wouldn't have to add a whole script tag. You could just break out with a quote sign and add like an on-mouse over event or an on-load event. In Web 2.0, it's a lot more complicated, right? Because it's not just HTML that comes down and static JavaScript. You got all kinds of stuff coming down. There are dozens of different ways you can do cross-site scripting in an AJAX application. We'll talk about one of them. But the real point of this is if you are either attacking or defending an AJAX application, it's up to you to understand what the downstream protocol is and what's dangerous in that downstream protocol. We'll use one example. So this is a pretty common AJAX mechanism. I go to my site, maybe it's a mapping site, and I do a normal HTTP GET on that when I type it in the URL, and I get a bunch of HTML, a bunch of JavaScript that downloads and loads itself into my browser, makes itself at home, and then when it feels like it, it does an asynchronous post up using the XML HTTP request object, and then asynchronously gets back JavaScript. And then when it gets that JavaScript, it evals it. It just runs the JavaScript. And the whole idea of doing that is often you're either using that JavaScript to create data structures that are then looked for from different parts of the JavaScript, or it's a callback. And I can declare in that callback, maybe this asynchronous XML post is, I want to get the latitude and longitude for where I'm looking on the map. And the function that comes back is print latitude and longitude, right? So it's a great way of making state go with the request because the JavaScript that comes back knows what it's supposed to do. It's very, very common. In this case, maybe we're doing downstream JavaScript arrays. So now we've got attacker-controlled input being sent down in JavaScript arrays, which is dangerous. And in this situation, maybe I've got a form field that gets shown on somebody else's site, and it has to get down as a JavaScript array. And so everything that's read here is something that I control. And what I've done as the bad guy is I've given it an item to put in this downstream array. Maybe it needs to not be null or empty, so it works. And then close off with the double quote, close off the quotes that are already put there by the JavaScript. And then I terminate the line and actually do a whole nother JavaScript function. It would be very, very convenient if this web site I'm attacking had something called do bad stuff that did something bad for me. Most likely that would have to be something much more complicated to actually do whatever payload, whatever bad thing you want to do. And then you close it off and you create a new variable so that you can have those quotes and that semicolon at the end actually means something. And this gets run intentionally by the browser, right? Why do I care about the quotes and stuff? Well, whatever I do, and one of the things that makes this complicated is I absolutely don't want to break the JavaScript, right? Because the eval is going to break and the whole thing's going to break down, and they're just going to get an error. They might not know they were ever attacked, but your payload's not going to run. And as you can see, lots of stuff that people used to look for, like brackets and script and on mouse over and all the kinds of things people used to have in their XSS blacklists, doesn't have to exist anymore because I'm already injecting stuff into a running JavaScript engine. And so the domain of characters is much, much larger. What if this was, instead of an array like this, a custom serialization where the pipe object is instead of equals, right? Which actually you see situations like this, or some unprintable character, or it's a semicolon, or they pick something totally random because they don't want to do input filtering and they don't want a collision with the inputs people do, right? Which happens. That's why it's not easy to kind of come up with a generic statement. But overall, AJAX app make this, because people are no longer, maybe they still have the same old cross-site scripting filters on their app. They're using the same ones that they wrote before. It opens up cross-site scripting once again for you. Often, if a cross-site script that comes down, maybe you're not able to break out of whether the serialization is. Maybe they don't allow you to put quotes in. Maybe they don't allow you to put brackets in because they've seen this talk and they're like, oh, well, I know I'm using JSON and I know what's dangerous in JSON, right? Brackets are dangerous in JSON and quotes are dangerous in JSON, so I'm going to disallow them. And I'm going to do input filtering. But I don't care about the less than and greater than symbol because those don't do anything anymore. Well, all of the stuff that gets sent down in an array to change a GUI has to get written to the GUI's DOM at some point, right? And this is where it gets a little complicated. This is a very simplistic situation where I'm doing a document.write to modify the DOM and make the page change. But if you can inject script elements, you can inject script that gets injected as child elements for different parts of the DOM. There's lots of different ways that you can get into a payload that perhaps it doesn't get attacked immediately upon deserialization from the server, but later in a delayed situation when that actually gets written into and the DHTML updated, then it actually your trap springs. Cross-site scripting could already be in the DOM too. And this is, you don't have to actually, this is a situation like if I want an AJAX app that has some pretty complicated script that reads from things like document.location to pre-fill some fields. that I can get a referred cross-site scripting bug is because I can send you an URL that then controls document.location, or I can control document.refer. But sometimes Ajax, so I'm sorry, is there any questions on kind of the basic ways of JavaScript getting sent down or either getting written in later? So Ajax apps actually introduce a whole nother kind of cross-site scripting, which is the good old traditional kind, but something that's not expected, which is cross-site scripting outside of the context of the actual app, right? So let's say we have a situation where an Ajax application takes a get and gives you back script, right? Our same old application. Let's say it's webmail.com. Webmail.com likes to take get requests and give you JavaScript or JSON arrays or some kind of weirdly formatted thing. It really doesn't matter what it is, right? And so I, as an attacker, open up an account at webmail.com. I send myself an email with script in it to see how it's formatted. I read my email, and while I read my email, I'm watching, because this is a cool new Ajax site, right? And when I read my email, it doesn't change the URL up top. But I'm watching in WebScarab, and I see that there's a request that goes out to my mail / getNewMessages.aspx. Obviously, it's running on a Java server. And the attacker sends, wow, that joke fell really flat. So as an attacker, I'm able to do this multiple times, and I figure out what the framing looks like, and what kind of input filtering happens, and what kind of characters I can get in without them getting escaped. And then I decide, I figure it out, and then I send the same email to my victim. And the victim gets it, and maybe he opens it up and says, wow, what is this junk? I don't know what this is. Because maybe they've seen this talk, and they're actually, I'm sending down script tags, but somewhere they're properly, when they send it down the JSON array, the JavaScript, they're not doing a full eval, or they're checking through it for something dangerous, or there's a lot of little tricks you can do with client-side JavaScript to kind of protect against attacks like script and JSON. They're doing some of those things, and he just sees a bunch of garbage, right? It doesn't actually work within the webmail interface. So I now send that victim a link that I want them to click on. That's at webmail.com, and that's the URL. And it's not the URL that you're supposed to go to when you go in the browser to make webmail.com work. It's the URL that webmail.com goes to behind your back to get the messages. You guys understand the difference? Because that's important. This is an URL that's not supposed to ever be exposed to a normal browser. And so the URL comes down, and it comes down with this code. It's JavaScript code, and I wasn't able to get this to work within webmail.com, but now I get a bunch of code that comes down, no HTML tag, no head tag, nothing like that, and it comes down and it loads in the browser. What do you guys think happens when this comes down to the browser? Obviously, the red stuff is controlled by me. Well, it turns out it's kind of determined on a lot of things. It determines on what the content type is in the HTML header, and it's determined on which browser you're running on. I can give you a guess which commercial browser likes to automatically figure out its content type for you. And it will automatically go through, and it looks at this, and it says, var message array. It doesn't recognize this as JavaScript because there's no script tags, right? So it just says, this is text. This is just text and it prints this out on the screen. And it keeps on going until it sees this script tag. The script tag that meant nothing in the context for the webmail because it was in these double quotes before, right? And I wasn't able to break out of the double quotes. But now, it's not in the context of the webmail reading it. It's in the context of the browser seeing this and nothing else. And it says, oh, thank God, it's my first HTML tag. I need to start a script element. And so it runs the script inside of it. So now you're thinking, why do I care, right? This isn't running within the webmail application itself, but it is, right? Because I sent a link to a person using their webmail. They're guaranteed to have a webmail cookie. When they click on it, they go to here, it's running, it thinks, in the context of webmail. It can do whatever it wants. It can steal a cookie. It can access webmail as the user. It can do whatever it wants, even though it's not running within the app itself. It's an attack against the browser with a referred cross-site scripting, right? I generally have to send somebody a link that they have to click on. It's not stored, but it's kind of stored too. So it's kind of a weird hybrid attack that actually you see a lot. Because, even if you can't, this is a good backup if you can't get a cross-site scripting attack to work within an Ajax app. I lost my first person. Goodbye, sir. Have a nice day. So, I'm sorry. No. They're not reading my email. I sent them the same link.
You sent them 2 emails?
Yes, exactly. No, I sent them 2 emails, right. I'm sorry, I came up with this big hypothetical where I'm a stupid attacker and I want to try things out, right. And I tried the attack first and it didn't work, And now, so I sent it to myself to see how it worked, and then just sent them a link to their mailbox. And this is assuming that the get link doesn't have something unguessable, like a GUID that represents. So it's not for like just getting the message, but maybe if you get the entire inbox, that's probably a request that doesn't have anything that's specific for the message. I'm sorry, miss? It will think that script is running because this script comes down from webmail.com. I never said Gmail. I don't know who you're talking about, Gmail. This comes from webmail.com, which probably belongs to somebody, but somebody with less lawyers than the people that own Gmail. So, no, it thinks because this comes from it, the browser doesn't know that it was never meant to see this URL, right? It doesn't know that this URL was only supposed to be accessed by the XML HTTP request object. So it comes down from webmail.com, and so it can read the cookies. Right. They click on it, and they go to a new page. I'm sorry? So they will look at this, right? This is code that webmail.com's client-side code was originally supposed to run this, and you can see I don't have any double quotes in here. Maybe they know about these kinds of attacks, and so they're filtering out double quotes. And so if they actually look at it in webmail.com, it's very possible they're just going to see this script, written out as script. The point is, if they then just go to the URL itself, instead of the URL being pulled down by XML HTTP object, then the script runs and grabs their cookie. So, and I'm guaranteed that they have a good cookie because the only way they could have clicked on that link is if they were logged into their webmail. And I can explain it offline too later. So cross-site scripting has gotten a lot of press from MySpace. And it's interesting because the MySpace worms, the cross-site scripting bugs are just normal cross-site scripting bugs, right? It's the kind of cross-site scripting bug that you would get that, say, if your entire business model was 13-year-olds are allowed to write HTML, and I'm going to determine what HTML is or isn't allowable, but I want them to be able to do things like upload MP3s and movies and JavaScript-enabled Flash picture frames and all this kind of crap that you see on MySpace pages, which are now a supported part of the community. To say you're allowed to do that stuff and then to create a blacklist of the things that are actually evil is a little difficult, right? And so they just have standard good old, there's number 2, standard good old cross-site scripting bugs. I was hoping that I would intimidate people not to walk out anymore by pointing them out, but standard good old cross-site scripting bugs. And so those aren't actually that interesting. What is interesting is what people are doing with them. And this is a thing called the Sammy worm. Anybody remember this thing? Anybody become Sammy's friend unintentionally? Right, and so this is called the Sammy worm. He just loaded this in with a good old cross-site scripting bug. And the only thing that's really interesting here is not that he was able to get it in, it's that he's using all these Web 2.0 technologies, like asynchronous XML HTTP requests, to do something dangerous. And I've highlighted a little thing in red that says, you know, he does an initial request and then he parses it, and he looks for a thing called the hash code. Why do you think MySpace has a hash code? Well, they have it because of, look at the segue, cross-site request forgery, also known as cross-site reference forgery. This is another acronym that's going to get fought over. It can be abbreviated XSRF or CSRF, but I'm going to call it XSRF, and hopefully we can try to make the standard. We can all agree in this room to use cross-site request forgery and XSRF, and that will be the end of it, because everybody in here is all the most influential people in web application security, right? Yeah. So anyway, it's really kind of the new hotness in web security. If you haven't heard about it 4 or 5 times in the last 6 months, you're not reading enough. Why is it the new hotness? Because it is an attack that, like cross-site scripting, allows you to authenticate, to interact with the site as an authenticated victim. And it allows you, like parameter tampering, just to ask for something to happen. But in this case, you're probably not even asking for something that's disallowed by the business logic. Annalie, you can sit up here. Hi. And it's very poorly understood, so it's everywhere. Literally, almost every single web application we look at professionally has XSRF. That doesn't mean it's always really something you care about, right? Because there's only some situations in which XSRF is really important. But it is a problem if A, your site does something, if B, your application is actually popular enough to attack, because generally XSRF attacks are probabilistic. They're not aimed at one person. And C, if your users tend to have cookies. If you have an application where a lot of my users have cookies at 1:30 p.m., right? That's the kind of, if those kinds of things are true, then this is a big deal. And you can read an excellent paper. That was a very early paper on XSRF. He calls it cross-site reference forgery, but he's going to change that soon, by Jesse Burns, who's sitting right up here. An excellent paper. You can get a lot more detail on it. So what does XSRF allow? Well, the best way to tell this is to tell a true story, a true, really bedtime nightmare story about a man who is a little foolish in his web browsing techniques. So there's a nice little victim, and the victim's a yuppie. And because he's a yuppie, he likes yuppie porn. And the best, most addictive type of yuppie porn is that little ticker in the bottom right corner of your screen that tells you what your net worth is, right? And all of the different stockbrokers, online stockbrokers have this ticker because during the 90s is what everybody did during work was actually just watch what their net worth was, right? That ticker is often a Java application. It's a Java applet running in a iExplore.exe window or a Firefox.com window, but in a full HTTP browser window, and it generally has a cookie because it has to be able to ask the servers, give me my portfolio, and obviously you want that authenticated, right, to give somebody their portfolio. So the victim is browsing the web, and he's got his stock ticker going, and he's looking for inside information so that he can make more money, and his little stock ticker goes up. And so he goes to finance.yahoo.com, and he reads a message saying that somebody has some leaked news, and he clicks on a tiny URL. Never click on a tiny URL. It's either GoatC or it's a cross-site request forgery attack. I don't think they point at anything else. And he clicks on the URL, and he gets redirected to a page called cybervillains.com/news, which he finds like kind of an odd for a financial news site. But he's looking for inside information, so maybe that's okay. So he saves a minute spending, he just sits there and reads a story, and then he gets bored and he closes the browser. Okay, doesn't sound like anything happens. Well, a couple weeks later, he gets his monthly statement and $5,000 is missing. Like I said, this is a true story. Now, the kind of lie part about it is that both the victim and the attacker works for us, and we are paid to do this, but we've actually done this multiple times, and this is a great way to steal money from people. And if somebody figures out, hopefully not because of this talk, a good way to do this across multiple people, they might be able to steal a lot of money in a short period of time. What happened? So what happened while that victim was reading the story? The victim, the story page that came down that he was reading actually had a lot of script in it, and it also had 5 iframes. And those 5 different iframes had pre-populated HTML forms. And those forms, once submitted in order by the script, did these things. Those went to the bank site as the user and changed the user's email notification setting. It then associated a new checking account, which happened to be our checking account, to that user's online account. And then it performed a balance transfer saying, hey, please send a check to this new checking account. And then it deleted the checking account and then changed the user's email notification back. All there was the log that it happened, and the $5,000 had gone away. It's probably easier to understand if we look at a nice little graphic, right? So on the left, that's the guy's browser. I'm not going to tell you the brand of browser. It turns out basically all browsers are vulnerable to these attacks. This is part of the web. It's not really a browser vuln. And the guy already has ticker.stockbroker.com as a window that he has open, and it's got Java running in it, and he's got a cookie there, right? That's a cookie that's valid because he put his login in and he got the cookie back. So he goes to cybervillains.com and asks for the news site, and we say, yes, here's the news site. And so the news site gets rendered in his browser, and while he's reading the excellent story, he doesn't notice those 5 iframes, right? Those are those little dotted lines, those iframes that exist on the site in the script. And so those iframes, all they do is they point against stockbroker.com and they say submit. And it does 5 in a row, and there's a nice little timer to make sure that they happen in time. Why are they able to do this? They're able to do this because these requests have predictable information in them, right? They're HTTP posts that have things like, if I do a post against /transfer, and then all I need is an amount and the number of the checking account that it goes to, and then those are kinds of things that are predictable by an attacker, right? The way this attack really works really well is if this website that this guy reads works for anybody that goes to stockbroker.com, right? I'm not targeting an individual person. It just happens to be that all the stockbroker.com needs from you to do something on your behalf is your cookie and the request parameters. And all the request parameters are nice and very predictable. So this is Web 1.0. This exists right now. This is a bug all over the place. Nobody really understands it. And it's horrible. And like I said, if somebody figured out, say, they looked at the top 10 online stockbrokers, and they figured out that 4 or 5 of them have cross-site request forgery, and then they wrote a page that targeted all 4 or 5, and then they posted that page on Yahoo Finance during the day, where you're pretty much guaranteed that half the people are logged into those top 10, four or five, the 4 or 5 of those top 10 browsers, then you might be able to steal a lot of money in one afternoon. So the moral of the story, like I said, it used HTML form posts, although gets are even worse. It filled those forms with easily guessed information. It used a cookie, which is what the security community's been telling people forever. Use cookies, don't use hidden fields. Well, we've kind of been lying to them, right, all these days. Sorry about that on behalf of the security community. There's nothing random or encrypted, and there's really, they had a long lifetime cookie that existed because, this is really a probabilistic attack that the guy clicked on the link, or clicked on the link in his email, or clicked on the link on yahoo.finance.com while his cookie was valid. And this is probably about the worst case scenario, and unfortunately, this kind of worst case scenario you see a lot. So in Ajax, what's different? Well, in some ways, this is better. In some ways, it's worse. It's better because XML HTTP, the things like cross-site form posting, anybody know why that can't be fixed? Why that can't go away? Anybody want to hazard a guess to what kind of things absolutely require cross-site posting to work? Not ads, but we'll talk about ads in a second, but thank you for the... Anybody? Why do you think that HTTP cross-site HTML forms are allowed? Not mashups. It's something much more simple. You ever gone to your bank, and then you logged into your bank, and then all of a sudden you went to your CheckPay site, and the CheckPay site's checkpay.com, and the bank is bank.com, right? How do you ever wonder how checkpay.com knew who you were? It's because when you did that, bank.com had an iframe that did a cross-site post to checkpay.com with some kind of SAML token or some kind of encrypted cookie, and then they responded with a cookie that got set, so when you went to checkpay.com, you had a valid cookie that authenticated you. All cross-domain single sign-ons, almost all of them require this to work, and so it'll never get fixed. So fortunately, though, when Microsoft created the XML HTTP request object, and then Firefox copied it, or Mozilla and everybody else copied it, they were able to start from scratch, right? And so they're able to start from scratch, and they had a very simple security statement, which was, we are not going to let XML HTTP talk to anybody but my document.domain. Document.domain being a variable in the DOM, right? And document.domain is initially set when it comes down to the server that gives you the page, right? It can be reset by JavaScript, but you're only supposed to be able to set it to things that are in your up to the second level domain, right? So if I'm coming from www.bank.com and I'm script, I should only be able to change my document.domain to bank.com. That actually is a flaw. I'm not going to talk about it in detail, but who here in their company is at somebody's desktop, bobsdesktop.corp.company.com? Okay, well, it's everybody in here, right? Almost everybody has domain DNS names that are given out dynamically. Well, what happens if you go to a website on your friend Bob's computer, and then his script comes down, it sets the document.domain, and now it's able to interact with actual company.com, and company.com happens to also have your 401k, because you work at a company that does 401ks, right? So that is kind of a flaw too, but generally XML HTTP object isn't that bad, right? And it only allows communication with the origination server. But the ways AJAX are worse from XSRF is that like the kinds of things that people get automatic protections against XSRF are things like the ASP.NET view state parameter, or things like wizards that are created by their Java web servers. It's big tokens that come down that are encrypted and aren't predictable, that are for multi-state forms. Those kinds of things give them protection, even though they didn't know about it. But in AJAX, you don't have that, right? Because the whole idea is all the calls are asynchronous. So people will probably go through and they try really hard not to have dependencies like that. Many frameworks use gets for doing RPCs. In the HTTP stack, gets are only supposed to be for retrieving information, not for setting information. But somebody didn't read the spec before they wrote, everybody doesn't read the entire spec before they write their web app, which is a big surprise. And so gets actually often do things that are important. And sites that return valid JavaScript are very, very vulnerable. And that's what we're going to talk about right now. Why are they vulnerable? Well, there's a thing you can do called a dynamic script node. Now, this is script that's running in that cybervillains.com news story, right? And in that cybervillains.com news story, let's say that stockbroker.com has a nice little AJAX app, right? And so in that script, what I do is I actually create a script element on the fly by writing it into the DOM. And then I point that script at stockbroker.com. Why is that allowed? Somebody said it earlier. John? Advertising, yes. Has anybody ever looked at how AdWords works, or how Google Analytics works, or Yahoo ads work? All this tracking works because you can source a script that comes from somebody else, and you get it, and that source sends the cookie, the tracking cookie, right? Because they don't use images anymore, right? Because you can use image tags to do this, right? Because image tags send cookie. That's how DoubleClick used to do it. But now they want lots more rich information. You ever wonder how Google Analytics knows if you have Flash installed, right? That's not stuff that comes down in the referrer header. It comes down because they're able to send you a script tag that comes with your Google Analytics cookie, and it also comes with all the script stuff that they're able to get, right? So lots of people use cross-site, I'm not going to say it's cross-site scripting, but cross-site script sourcing to make things work. And so I take my script tag, and I run it, and I source it from somewhere else. Well, why do I care, right? Like, why do nobody really cares about image tags. I mean, I can get an image from anywhere. Why do I already care about script? Well, when this was originally thought of, the whole idea of script was there was a big static thing that came down and did your stupid drop-down menus, right? Not that it was something that did something important and actually contained important information. And this is a real quote from a web application person. If you go around and you do research on cross-site stuff with Ajax, you'll learn that the web development community, the people that go to places like Web 2.0 conference or South by Southwest or all these cool Web 2, they think that the UN and the security community have gone together to take away their God-given right to cross-site HTTP request, right? Because they can't do things like Housing Maps has to, do all this crazy stuff so that they can get Craigslist and Google. You have to go through Housing Maps for them to grab that stuff. Well, they want to be able just to go straight to Google and go straight to Housing Maps, right? Or Craigslist, and actually just mash it up because it saves them a lot in bandwidth, right? And so they're so pissed about it. They're so pissed that XML HTTP request has all these security flaws. They have no idea why. And this quote is an example of, shh, I know a security hole, but don't tell anybody because we don't want it to get fixed, right? Because it's really useful for my stupid mashup site, right? Well, it turns out that's also going to be able to own up banks and stuff by doing this. Because say that script that comes back in your Ajax app is a valuable JavaScript, and it calls a callback function. So if I'm a bad guy, all I do is I create a script node, I source it somewhere else, and when that script comes back, it does a callback to something, and I accept that callback, and in a very friendly way say, yes, I do have that function you're calling, right? So in this example, maybe it's webmail.com, and when you ask for, you ask for the inbox, they send out JavaScript that calls these functions, add message, add message, add message, which then goes through and adds the message into the DHTML. Well, if I'm the attacker, all I have to do is create an add message function, and when that comes back, it calls my function, and my function gets all that data cross-site. And now I can just take that data and send it via a source or an image tag back to cybervillains.com, right? So what's the end result? If webmail.com does this, if they come to cybervillains.com and they have a webmail.com cookie, I can read all the messages in their inbox. It's two-way cross-site request forgery. It's a complete break of the browser security model. And it turns out that even if you're not just doing callbacks, if you're doing things like declaring new arrays and stuff like that, you can grab that. And Jeremiah Grossman had a great little trick where he overrides the array constructor and then uses the array constructor to get that data out. You can do the same thing with JSON, because JSON could just be evaled. This is bad. And it turns out this is in almost all of the Ajax frameworks. And we have a tool that does this, but I think we're running out of time, so I'll demo it to a small group later, or you can probably come download it off isecpartners.com later, as soon as I can get off of the BlackHat wireless network and upload it from something a little more trusted than no network in Clark County, I think, is trusted this week, actually. So what is the XSRF lessons in Ajax? Your application may be in trouble if your requests are guessable, right? If there's stuff in your request that's not personalized to you, then somebody else can guess what they are and blindly ask for them. If the requests are formatted as gets, gets are really bad. Posts, you can do the iframe trick, but you can do gets in a lot of different ways, and it's a lot easier to do things like brute force many gets. If gets requests return valid JavaScript, you're probably toast. How do you fix this? Well, there's a couple ways. One, if your framework wants to take a JavaScript down and then execute it, what you should do is put a bunch of garbage in front of it, and then have your XML HTTP request, make the request, pull that garbage off, and then eval what's left. And because that garbage comes down, you might be able to get around this problem. It turns out there's a bunch of different things, because the script element is a very, very featured object, and it has all these different methods that you can probably get a lot of stuff as an attacker out of it, and we're working on some of those things too. And if your request can be formatted in HTML form, a lot of Ajax apps still do all of their data in things that look like normal HTTP form posts. what's the future? Well, if the web developers get their way, XSRF is going to get a lot worse. And so just as an experiment, go Google for cross-domain XHR, right? And you're not going to see any discussion about security. You're just going to see bitch and moan about the security people won't let us have our XML HTTP request. This is the, yeah. And then up here it says Safari already allows cross-domain AJAX. Thank you, Apple. So on behalf of the BlackHat community, I'd like to say thank you, Apple. I'm not going to talk about that at all, but yeah. So Zane's going to talk about how you do this stuff in Flash.
So, since there are all those restrictions on the XML HTTP object, why not bypass it with Flash? So that's what some web developers thought anyway. With Flash 6.0, basically you can go to arbitrary sites and bypass those restrictions. Those restrictions are configurable by a policy file, they decided, which is going to be crossdomain.xml. With the introduction of Flash 6, by default, it matched your top-level domains. So foo.example.com could talk to bar.example.com, but not bar.cybervillains.com. So the policy file, we've got an example one up there, and what more often it looks like. It allows wildcards, which is great for us. Flash 7, when it came out, it tightened down the restrictions a little bit, and so that foo.example.com could only talk to foo.example, or could only, scripts that came down could only talk to foo.example.com. It leads to cases of frustrated admins, which when you search on Google Groups for Flash 7 cross-domain restrictions, you get a response like this. In my case, I simply use star rather than star.domain.tld. Also another thing with that is that the cross-domain policy files are no longer restricted to just the default one. It can be anything, so you need to look around to check for that. It's got another great acronym, FJAX. And with the proper crossdomain.xml setup, you can read and write arbitrarily whatever they specify. Why are they interested? Everybody remembers our login, which when you specified ++ in there, anybody could log in. Here's the new version for web apps. Cross-domain, or allow access from domain equals star, which is really surprising how much you'd see that. Because the web development community is really they really want this functionality. This is something to look out for in the coming years, and this is really, like Alex has been saying, really going to increase the XSRF attack surface. Like I said, you would be surprised as to where this comes up, seeing allow access from star. You can take a guess as to which one in here would be the most embarrassing. If they had Flash as cross-domain star, you'd probably be right. So let's take a look at the frameworks then.
So, I mean, the bottom line there is, if you go back to your company and they have crossdomain.xml and they say allow from star, the statement you are making is, I don't care if people authenticate as other people on my web application. That's what that means. So you can use it in some situations. If your web service is giving people temperatures, right, or you're like Craigslist and you're just freely giving out information, it's fine. But in any situation where people have to authenticate, it's bad. I just want to apologize to Johnny Long for this. I know we stole all his Google hacking techniques to be able to do this. I'm sorry, Johnny. Thank you. Okay, nobody was at BlackHat last year? No? Okay, so AJAX framework. So we talked about a lot of security bugs. Some of them may or may not be better or worse with certain frameworks. So we looked at 3 of them, and we tested them using the example demo applications that they give out. The 3 we looked at are Java Direct Web Remoting, Microsoft Atlas, and Google Web Toolkit to try to get a nice broad view of different platforms and different types of AJAX. Direct Web Remoting is very interesting. Obviously, it's for Java. And the really cool thing about it is you don't have to rewrite your application to use it. If you have methods in a Java enterprise container, all I have to do is install the DWR classes, and then I put in an XML file. I say, I want to expose these methods to the internet. So maybe those methods are transfer money and login and stuff like that, and I put that in the XML file. And without even recompiling or changing the code in my Java app, it magically goes in and wraps those functions and exposes them, and it generates JavaScript to automatically expose it to everybody. And it generates that JavaScript object that acts as a proxy. This is kind of your basic proxy-based AJAX, right? And it's nice and easy. It's pretty cool. But because it is a proxy, the proxy object itself, since it has no understanding of where you are in the state of the program, right? It's supposed to be just there for people to call. It has to know about all of the different functions you expose. And so as an example, there's two ways with DWR to find out all these functions. One is they generate these files that are big HTML documentation files for all the methods. And in all of the sites we looked at, these files were still on. So if anybody here knows Rainforest Puppy or any of those guys and they have control over what goes in the NICTO database, this is definitely something, right? Because if somebody has Java DWR, they might have a thing that says, this is all the functionality on my server. Please attack me. But the other way is, that's pretty simple, even if they turn that off, is that, like I said, they have a JavaScript file that comes down and that understands all the different functions and what arguments they take. And this situation is a very, very simple one. Cross-site scripting. The downstream traffic in direct web remoting is JavaScript. It's parsed and it's placed into a DOM. There doesn't seem to be any client or server filtering. The bottom line is this is a real screenshot. I do not rely on DWR for cross-site scripting filtering. Cross-site request forgery. Upstreams are gets and HTML form posts. Like we said, gets and posts within the HTML, name value pair is very easily faked, either by doing like an image or script tag for a get, or doing an iframe for a post. Sometimes there is this call ID info that's thrown in there that looks like, it doesn't look like it's truly like cryptographically random. It's probably random enough to make an XSRF attack not feasible. The downstream is available JavaScript. The bottom line is, without any custom protections that you build into your app yourself, if you use DWR, you're probably vulnerable to XSRF. Although the call ID prediction stuff needs research. It does not require the XML HTTP object, even though it's an AJAX framework. And so you lose all the protections of doing something like JSON with an XML HTTP that makes it difficult to falsify. Okay, Microsoft Atlas. Microsoft came out with their own AJAX framework. Obviously, it integrates on top of ASP.NET 2.0. This is not a proxy framework. This is more of a client-side rendering framework. The idea here is that you build something out in your IDE that looks like a file that ASP.NET would render and would create. So maybe I have like I have a big table, and I have like an ASP.NET table object, and then I just change the code a little bit, and automatically turns that into an AJAX table, right? So it's not like a proxy framework where it exposes all of these C# functions. Like, it's not like a SOAP interface. It's more like something that just changes the rendering of specific components. As a result, method discovery is a little bit more tricky, but not that tricky. And just like DWR, the methods are sent down in JavaScript and pretty easily parsed out and easy to read. Don't take this as a direct of any of these that we're directly criticizing them. I should have said that at the beginning. I'm just trying to lay out that maybe you don't want to rely on these frameworks to give you lots of protections. You still need to think about security. Cross-site scripting, the downstream JSON, or JSON-like functionality, and proper JavaScript. There is this thing called ASP.NET Validate Request, which seems to be perfectly fine working with Atlas, and it's turned on by default in all their demos. And so that's good protection. It's not perfect. I wouldn't rely on any kind of global protection for everything, but at least in all of the demos we looked at, the flaws were fixed. So that's smart. There's probably cross-site scripting would be possible, but this definitely improves the situation. XSRF are upstream JSON-ish or actual JSON by XML HTTP request. Those cannot be faked by using an iframe. There are some situations where there's single gets. There is no entropic or cryptographic information added to request by Atlas. As a result, functions that take gets and change state, which is tough to predict, right? This isn't like a procedure call thing. This is if you use a table versus you use a button versus you use a drop-down box, you get different functionality, right? And it's not really predictable. But in the situations, things that are provided by gets are probably able to be attacked. The posts are much more difficult to attack and probably not as much. But this one's difficult to predict because in the different demos, we saw totally different types of communication. Google Web Toolkit. Google has their own AJAX framework, which we couldn't find it actually running on any of their big sites. I don't know if they use it themselves that much. but they have this AJAX framework. It's kind of like Atlas in that it's not a proxy thing. It's meant for client-side rendering. And the idea here is you write a Java application that looks like what you want to be in the browser, and then they have their magic and their magic pixie dust, and the magic pixie dust turns the Java code into JavaScript that runs and does the AJAX stuff. It's pretty cool. Does require you to totally rewrite your web application, unlike DWR, but the results look pretty cool. The method discovery is much more complicated. If you watch the traffic from Google Web Toolkit, you see absolutely the most ugly JavaScript code you've ever seen, which pretty much means it's almost certainly intentional obfuscation. I don't think they did this because they wanted to protect against method discovery and parameter tampering. I think they did it because they wanted to protect their intellectual property. But you get things like this, which is just completely unreadable to anything but an actual JavaScript compiler. It does turn out that there are a handful of functions in a thing called a .cache.html file, functions that have underscores in them, and those underscore functions are customized per application. And so it's quite possible by getting those underscore functions that you could replicate a list of all of the functionality exposed by methods, but it would be pretty difficult. XSS is difficult to test and difficult to attack because they use all this crazy stuff on the wire. They don't use JSON. It's amazing. Google is using non-standard stuff for doing their stuff, which actually in this situation makes things a lot more difficult to attack. But doing fuzzing and playing with a bunch of different characters didn't seem to do any harm. Those characters just seem to come through encoded properly. So XSS might be possible, but it seems kind of unlikely. And even if there was XSS, might be a little bit complicated by the fact that they use such weird encoding formats. As far as XSRF, they use a custom upstream serialization, like the one you see here, which has obviously things like Java classes enabled in there and a bunch of unprintable characters. This uses XML HTTP request, and so therefore we're not able to fake it using an iframe or using a get. As a result, cross-site request forgery seems unlikely. This definitely needs more research to see if there's any places in which the Google Web Toolkit will use a simple get instead of a post to do any state changes. But in the little bit of testing we did, we couldn't find that. So what's the conclusion of our little survey of frameworks? We also looked at a bunch more that we didn't write up, but little ones. I mean, there's dozens and dozens and dozens of AJAX frameworks. None of the frameworks talk a lot about security. They don't talk about it in their documentation. They don't talk about it in their comments. It's not something they advertise. Atlas comes with this cross-site scripting protection that they get from .NET. That was the only situation where we saw like an obvious security precaution. Obviously, Google is probably doing something, some kind of input filtering or escaping mechanism server side. To protect against XSS or XSRF on all of these or in any framework, it's up to you, the developer, or the security person who's checking it to understand the traffic. You can't make any really global statements just from looking at the traffic. You have to understand how that functions. And it's hard to make global statements on the frameworks because they use gets here and posts here, and maybe they have JavaScript coming down here, and maybe they don't here, and it's often just dependent on the design of the app. And just overall, you never rely on other people's code. None of these things are they should all be obvious, but the real problem here is that these frameworks make it really easy to write web applications, and so you end up with an abstraction layer between the developer and the actual wire. And every time that happens, you end up with people that don't understand what's going on in the wire. They don't understand things like SSS and XSRF. So we'll talk about some future trends. It's kind of like we are moving to a web-based OS, like almost at somebody's business model for world domination. A lot of sites now have codes running from all kinds of places. People have things called plugins. People have things called gadgets. You can download even true for Win32 software that runs on your desktop, like Google Desktop has plugins that are written in JavaScript, right? So they're running on your machine, but they're running within an IE, within a IE scripting host. WindowsLive.com from Microsoft has all this plugin architecture that people can write all these plugins like, hey, don't you want to see all your friends' Xbox gamer cards and stuff like that? RSS feeds. Anybody here use an RSS aggregator that happens to be a web application? You know what you're doing when you do that, right? You're saying, I trust this aggregator. Maybe for you, sir, it's probably the Google desktop customized homepage. And you're saying, I trust that they are doing filtering on all this RSS when it comes in to make sure that there's no script in there that then runs within my context with my cookie. This is all complicated by the fact that Microsoft, Google, and Yahoo, the big three of the web, all use these single sign-on systems that have extraordinarily long cookies. And that let you sign into everything from your bank account to checking your mail to looking at your RSS reader, right? Which obviously stealing a cookie with an RSS feed might be more important than just getting somebody's RSS feeds, right? You might be able to get something very important to them. So I recommend you go check out these desktop managers and play around with them and think about, do you trust all the code running in them? JavaScript has no internal security model. It has a security model enforced upon it by IE or Firefox. It doesn't have a security model like Java does where you say, this function can only do this, right? Or this container can only do this. And so if JavaScript's running, it probably can do anything that all the JavaScript can do. And so it makes it really difficult to have a situation where we have some trusted JavaScript and not so trusted JavaScript. For example, this is a live.com page by Microsoft. These are all RSS feeds, but you can also plug things in like temperature gauges and all that kind of stuff that can be written by third parties. Who is responsible for this page? I've got an RSS feed from the guys that write IDA Pro. That was probably a pretty big mistake of me, right? But I'm taking script from there. I'm taking XML from them, and I'm putting it into my DOM. Right next to all this other stuff, signed in with a passport.com cookie. So as conclusion, AJAX is a fine technology, just like others, but developers need to understand it to secure it. Just like all these other technologies, we get the money and we get the cool stuff, and security comes way later. All of these old web attacks have become much more interesting, like cross-site scripting, and none of this stuff is really new. It's just we're kind of reliving 1999 and 2000 because the old bugs that people knew how to fix in the Web 1.0 world now are becoming much more complicated and hard to find, and there's lots of work left for research here. We can't leave web security for web developers. All they want to do is cool stuff, right? They're like kids in a sandbox. They just want to do cool stuff. All these security adults need to be around to do research to help tell them they can't. And so this is still a green field, and I highly recommend people look into it if you're looking for good research projects. So we are out of time, so we'll take questions and answers later, but thank you so much for coming. Have a great day.